Thank you so much， 感谢大家，我真的非常荣幸你们的邀请但是我也想说，我真的非常感谢大家，让我们的朋友来在我的生活，在我的城市上海。I will of course switch to English and thank you so much everyone for this kind invitation. TimePie has been a friend, many friends for many years, especially during the COVID time, so it's such a great pleasure to see some of those people for the first time in life. And I'm so happy to see a lot of my friends coming to Shanghai, to my hometown actually for the past 15 years. And yes, I'm really happy that just this Friday I became a part of the nation of China. Switching gears to health longevity medicine, I would like to bring us more from, let's say, not bench to bed, but probably more from mouse to the people, and bring a little bit of a context of clinical medicine, also to be continued by the next speaker, dear friend Andrea Meyer. So you will see some of the overlaps in terms of the society that we created together. So I will go briefly through the definitions and then talk about the tools, the protocols, also about the public sector in longevity medicine, and also about exciting things that we are doing at the Renji Hospital Jiaotong University in terms of longevity and digitalization platform for biomarkers, brain longevity, and finished by the Education Hub. So for all of those who saw me before and don't want to bother you, but I'm always opening with this slide that is showing the Red Queen and Alice running very fast, and then they stop, and Alice say, why are we in the same place? And the Queen says, we have to run double as fast in order to move forward, to be in the next place. And I think this is exactly what longevity is doing. Science, the AI, the computational science, and of course, medicine. We are constantly trying to not only keep up with the speed of all the fields that are evolving, biotech, AI, and others that are flowing into longevity medicine, but especially also in order to bring the field forward, we have to work even double as fast. And also in terms of definitions, it's important to know what we understand under longevity medicine. That was one of the first definitions we tried to establish in the year 2020. Of course, not claiming that it would be the only one, but it was a first nice attempt to formulate that longevity medicine is a branch of precision medicine that is really focusing on healthy lifespan, so on health span and lifespan, and is powered by AI technology. And that was done in collaboration with Professor Sheba Longevity and Dr. Li Kai-Fu, who is really the AI person. And then, I think 2 years later, or a little bit more than 1 year later, in August 2022, the Healthy Longevity Medicine Society was created, and both of us, Professor Meyer and myself, we were working on it for a while, and the society was established really to bring the MDs together, the clinicians together, but of course not only, but there was a little bit of a gap that the doctors, the physicians, the practicing clinicians didn't have their spot and their association, their society where they could exchange, have clinical cases, and also work together on clinical guidelines. And that was then established in 2022, and this society came together for the first time in Singapore, and we were brainstorming about potential definition of longevity medicine and came with the following above, which is optimizing health span by targeting age-related processes along the lifespan. This is the executive committee, and as you can see here, I would just like to point out that people who are inside, they are really representing different fields, stem cells and senolytics and neuroprotectors, but also psychiatry and brain sciences and mental health. Professor Pinkus from Columbia is the head of psychiatry and mental health. So, because very often when we speak about longevity, we're focusing on the body and the omics, and yes, we do talk about cognition, but actually brain health is a little bit more than that. So to keep that in mind, we also, of course, included that important field. And another exciting news is that longevity medicine is really entering also public sector. Academic hospitals are establishing longevity departments, and it's very nice that we are collaborating and working together, exchanging our processes, news and protocols. And as you can see here, there are at least 3 of them already in Singapore, in the Alexandra Hospital, in Sheba Medical Center in Israel, and also coming up in Mayo Clinic. But many more are coming up, and hopefully also very soon here in Shanghai at our Renji Hospital, we will have also a longevity department. So those are just a few of the opening moments of the Israel Public Department. This is how it is looking like, but that's just one of the examples. Luckily, more even private clinics are really embracing the idea that they will not only serve as a service for patients, but also embrace longevity education and research. And also, through this, we can build bigger networks in terms of data exchange and data science, not only combining the basic science and then interventional studies, clinical trials, but also building together really a nice way of a data platform that we can exchange and have even more conclusive expressions from it. And another example are, as I mentioned, also things that are happening all over Asia. For example, in the Philippines, there's also a clinic that just opened, Gaia, which is more of a digital clinic, and working a lot with what we are usually seeing in those clinics, right? So apps, platform, very, very precision-based gaining of knowledge of a person, very individualized, and very targeted interventions and then follow-up. So that's very exciting and very, very good. However, when we go back, and some of you I know in the audience are also physicians, are clinicians, and we still have to, go ahead and treat the sick patients. Myself, I'm just coming now from a night shift. It's still very important that medicine will embrace the field of reacting to a disease, helping the person. And of course, we also have the preventative part. We have the primary, secondary, tertiary prevention. It's important to detect the diseases at an early stage. No question about it. And there are very, very good national programs. There are very good screenings. Nevertheless, how much more important is it to actually detect and prevent the risks of diseases rather than the early part that is already developed. And this is what longevity medicine brings along. So this is not something separate, this is not something that is claiming to be better, it's just something different and missing in order to bring better, healthier years in the lives of people. And as we know, the main point right now, or the main challenge, is that our health span, so the good years of life, the healthier years of life, are much shorter than the entire lifespan. People live longer, people are less productive, people are more frail. And what we are trying to do is really to close this gap between the health span and lifespan, which is not only beneficial for people, for those who are at risk of the diseases, for those who take care, so the caregivers, for the, of course, healthcare systems, but also for the society at large. And of course, this changes a little bit the paradigm of how we work with patients. So as you can see here, of course, our normal understanding of a journey of a patient, each of us, as being born, we go through this part of life where we are usually assessed by pediatricians or one doctor who is guiding us within a range, within a frame of chronological age and normalized standard values. One size fits for all, more or less, you are under the curve, and then you reach the so-called peak performance level, so the individualized peak performance period that is usually very short, and right after that we have the decline. Continuous and accumulated decline of function and performance, accumulation of diseases, multimorbidity, polypharmacy, being treated by different doctors, and again, here always also assessed within the chronological age, within standardized norms, the typical too high, too low versions that we have in the hospital until the disease. In longevity medicine, as you can see, we are not really changing the path here. We are not transhumanists who are trying to extend it to forever. That's a little bit of a different approach. What we are trying to do is really to optimize this part here. We're trying to optimize the part where there is a decline of function, where people are getting diseases that are mostly associated with aging processes, with aging itself. For this, we are of course using plenty of data, which you have heard in many of the great speeches here, ranging from the omics to the imaging, through the functional testings that we know, through the epigenetics, activities, blood tests, and so on, and with variating, of course, AI techniques that are exploding actually right now and giving us a lot of potential. So back in the year 2015, starting with deep neuronal networks, right now with great advances of generative AI, which was already actually applicable at that time, but right now it's at least more popular. We are able to assess the biological age of a patient and to also estimate the optimal biological age of the patient and try to bring the patient specifically then to that optimal biological age at which the patient still can perform at his or her best at that specific point of time. So it's really a formula of time and current status and biological data. And for this we have a variety of diagnostic tools that we have, and beginning to have some of the interventions. I think the parallel session of biohacking is trying to provide few of those options. However, for us in longevity medicine, if we're working with people, we need to have more data, evidence-based, safety, efficacy studies to actually move it forward. And in order to have those, we need proper assessed and approved biomarkers. So I know that Dr. Maya will talk about it for sure in greater detail. Now, in order to fish out the right biomarkers to really assess which one of them would be best as endpoints for randomized controlled trials, we need to have also a lot of longitudinal data that are assessed correctly and collected appropriately. Therefore, an example here is, for example, the HLI assessment, where you have for Tesla MRI and other radiological testings, and the whole omics, and of course also functional testing, liquid biopsies, whole genome sequencing, polypharmacy, and so on. And polygenetic risk assessment is actually something that is very valuable. It is looking not only at the mutations that are leading to diseases, so not only the pathological mutations, but also really the polygenic mosaic of the genes that are then assessed to be related to a potential increased risk of some of the diseases that are actually much more interesting for us, because those are the diseases that are literally causing the decline of function, frailty, and disease burden. Also, pharmacogenomics is very powerful and useful for the daily clinic, so that we don't over or under treat or fully wrongly treat a patient. It's a very valuable information for each of us. And of course, liquid biopsies. Liquid biopsies that are now available commercially and are very helpful. Of course, we have to have caution here. As you all know, there are very often false positives, so we know what should be done to reassess the patient. But still, it's a very valuable tool, because even if there is a high false positive rate, it's still, higher than zero in no knowledge of potential risk of cancer. And then the entire field of trackers, monitors, something extremely powerful right now, even in the field of sickcare and medicine. It's giving us really good and valuable information longitudinally, even if they are not point accurate. The trends that we are gaining are very powerful. So for example, using trackers for sleep, polysomnography rings, or of course, CGM are very, very nice, but also we have now continuous cholesterol monitors, we have keto monitors, and others, digital pathologies that are available relatively easily, and many, many others to collect the data and correlate them with our objective functions. An interesting thing, hopefully, for you will be to know what we are doing also in our hospital, Renji Hospital. We are building a platform that is a smart platform, digital platform, as many, many hospitals here in Shanghai and all over China. However, in several of those points, Renji is really outstanding. We have a very large number of patients, especially in outpatient and inpatient, in terms of interventions, so short-term post-interventional stays, etc. Why is it important for us also still to bring it further and to build the so-called smart hospital and smart management? On the one hand, of course, to make it easier for everyone and to make it easier and approachable for aged people, also to lower down the burden of actual physical coming to the hospital for those who really don't need it. But also in order to gather data and for disciplines to work even better together. So the typical standard of a tumor board and expert assessment is now very, very often being done every day, several times a day on the internet. And we already have data being collected now from over 50 disciplines all of the time since the year 2020, so in the year 2023, it's been already exceeding 15,000 visits, and right now it's more than, I think, 15 million of visits with the data that is being created. This is important also for the fact that all of the data that were collected prior to 2020 and are being collected prospectively in a much better way, in a very, very proper way in terms of collecting of the biomarkers especially. Everything is stored in the same platform. Of course, a lot of things are being powered by the generative AI, so the patient is being guided, and also the structurization and the OCR is being applied, so the old paper files that we have are being now currently updated and brought into the platform. And further technologies are being brought from outside, so for example, blockchain is implemented in our reproductive department. We have also a lot of other networks that are directly connected to nursing homes, where patients actually don't usually have that much of digitalization themselves, but in terms of networking with the entire institution, it's working well. And of course, then it's expanding with outside partners, as you can see here, with large platforms that are collaborating with us, and especially with insurance companies, because last but not least, we want to have insurance companies being involved and helping us. So why is this platform also helpful for longevity? Because the way of granularization of such a platform is allowing us to tailor a protocol, to remind us properly, to bring the patient back, to have a follow-up for patients in order to get the right diagnostics that is needed within a longevity protocol, and also, of course, to help us to better assess which supplements, which further blood markers will be needed, which other diagnostic tests along the time. And that would, of course, encompass everything from the omics, as we mentioned, through the metabolics, but also more and more the neurological findings, and also the mind and body balance. Of course, microbiome plays a very important role, and more work is being done on the musculoskeletal part with our rehabilitation department. Why is that important? Because we know that our system, our bodies are not aging at the same time. They have different times of decline at different levels, from the cell through the tissue, through the organs, onto the system. And so far we were only able to measure indirectly the decline of the function, indirectly the reduced eGFR or kidney decline, the indirect body supply with oxygen and so on. But now we can update it. We can update it with biological aging clocks. We have a variety of them. They are now also very nicely developed here in China from several cohorts actually, and they are more organ specific. But for those that are available commercially, we have biomarkers of aging and biological age measurements also on different levels. Of course, the most important is the methylation clock, the genetic clock, but we also have quite good blood age, so really hematologic clocks. More and more, the brain age is being popular, so measurement in terms of MRI, and also several others. How they relate to each other, what are the actual proportions, how do they scale, this is still work in progress. What we are using a lot in our studies, in our cohorts, also in the sick patients, are those clocks, especially the hematologic clocks, because they do not require the actual blood sample, but also all the other clocks that are available, including picture clocks. And we can then assess not only what's the patient's chronological age and biological age, but also which of the parameters are not optimal and where is the optimum, and track the patient along the time. Sometimes those clocks can help us actually to reveal some underlying diseases that we didn't know about before. For example, this patient was biologically older than chronologically, struggled with reproductive health, and through those measurements of the biological age, since we know that they also correlate very often to autoimmune disease, we were able to detect quite a rare immune disease in this patient, and on top of this also Wegener disease, so very much aligning with the problem. One last word before I jump to the end is that we are also collaborating very closely in the clinic with AI-based drug development. We are just very lucky that in Silicon Medicine is just around the corner in Suzhou, so we are able to have the samples that are going through a high output robotic lab, and very quickly there can be a targeted identification for not only diseases, cancer, immunological, but also more and more so in terms of senolytics and geroprotectors. So that is something that we are using and working closely with Dr. Jabrankov and Dr. Ren in Suzhou and Shanghai. But I think the most important and most interesting part is really that the lab that is fully AI-based, so no people at all, is now in the process of being miniaturized, really put very, in a compact way into the hospital so that we can actually have an immediate and instant point from the patient through the lab to hopefully at some point of time compound synthesis for the patient. And we are also working in the sick care, right? So we are trying to implement this longevity concept into our daily work in our hospitals. This is being done in several things. For those of you who know this article that published a while ago in Harvard, it was talking about the correlation between biological age in patients or in individuals that had the disease, such as COVID, but also for those who were pregnant or had some other type of physical change, their biological age went up, and then after they resolved their inflammation or the pregnancy was finished, the age went down. And something like this we also saw in several other studies. For example, in cardiology, we did a study in New York in the department that was treating the COVID patients in the early 2020. We were confirming and actually were able to build a score predicting that biological age was correlated with higher mortality and morbidity, and that biological age was actually a much better predictor of worse outcome than any other of the individual scores. Later on in cardiology, we're also facing the development of biological age-based clocks for specifically heart values, and we had a study in Italy, in Napoli, on a big cohort of 50,000, yes, I'm going now, that was also showing that the biological age was a great predictor of an early heart failure. Right, I will skip at this point and just mention that for those who want to learn a little bit more about our education hub, that's a nice way and a very easy way to get informed, and it's for free, especially for medical doctors. And I will just leave the slide here. There we go. It's also available in Chinese language, and it's for free. It's on our platform for physicians, but not only. Thank you so much for your attention.